In this video, I'm going to be doing a couple more problems involving polynomials. Here we have a polynomial, p of x equals the product of x minus 2, x minus 5, and x squared plus 1. And we want to find the real zeros. Okay? So we have p of x equals x minus 2, x minus 5, and x squared plus 1. So to find the zeros, we set p of x equal to 0. So this implies that x minus 2 times x minus 5 times x squared plus 1 equals 0. And from what's called our zero product property, we know that when we're multiplying if let me go on the side over here, if a times b equals 0, this must mean that either a equals 0 or b equals 0. Think about that. There's no way that you're going to multiply two numbers together, three numbers, five numbers, how many ever, and get 0 unless one of those numbers is 0. So let's use that property here. The fact that all of this equals 0 means that one of those things must be equal to 0. That is, x minus 2 equals 0, or x minus 5 equals 0, or x squared plus 1 equals 0. So with the x minus 2 equals 0, I'll get the x equals 2. That is, when x equals 2, this is going to be 0, and thus when I multiply all these three things together, my result is 0. Or here, x minus 5 equals 0 means that x equals 5. That is, when x equals 5, we get that this multiplication is 0. Or here we get that x squared equals a negative 1. If I take the square root of both sides, I get x equals plus or minus the square root negative 1, which equals plus or minus I for those of you who have done imaginary numbers. And so that's not a real number. There's no real number that's the square root of negative 1. So for this question, we can X out that one because that's not going to be in our solution because it asks for the real zeros of our polynomial. So let me state the answer here. Therefore, our real zeros are at x equals 2 and x equals 5. Okay? Let's do another problem before we close this video. Find a polynomial p of degree 3 such that negative 2, negative 1, and 4 are zeros of p, and p of 1 equals 2. Okay, so if you've done your reading, you should know that, I'm going green here, that any polynomial of degree 3 can be written as p of x equals k times x minus, let's say, r1 times x minus r2 times x minus r3. That is a polynomial of degree 3. All polynomials of degree 3 can be written in this manner where r1, r2, and r3 are the roots. So we get that p of x equals k times x minus r1 is going to be x plus 2. X minus r2 will be x plus 1. And x minus r3 is going to be x minus 4. Okay? So now what's left is we have to figure out what's k. So to figure out what k is, let me stay in red there. So I want to figure out k, so we use this fact here. That is, we use the fact that p of 1 equals 2. So I set p of 1 equal to 2, and I get 2 equals k times x is 1. So I get 1 plus 2 is 3. X is 1, so I get 1 plus 1 is 2. And x is 1. So I get 1 minus 4 is a negative 3. Okay. That is P of 1 equals 2. So we put a 1 in for everywhere there's an x, and we set it equal to 2. So I have 2 equals, put a 1 in there, a 1 in there, and a 1 in there. And what do we get that k equals? So multiply here on this side, and we get what 3 times 3 is 9, times 2 is 18. So that's going to be a negative 18. 2 divided by that is going to be a negative 1, 9. So we multiply all this out and then divide both sides by 18, negative 18, and we get k equals a negative 1/9. So we get our answer. Therefore, P of x equals, if we look here, P of x equals a negative 1/9 times x plus 2 times x plus 1 times x minus 4. Okay? Okay, now just for fun, let's multiply all that out and see what this is going to be once we expand it. Let's go here. So P of x equals negative 1/9, and the first thing I'm going to do is multiply, say, these two. So that's going to be x goes to x, gives me x squared. X goes to 1, gives me plus x. Now 2 goes to x, gives me plus 2x. And 2 goes to 1, so that gives me plus 2. Okay, and we still have the times x minus 4 out here. Okay, is there any simplifying I can do in there? So yes, this equals negative 1/9 times what? That's going to be x squared plus 3x plus 2 times x minus 4. Okay, continuing on. Now multiplying these two. So we distribute the x squared, goes to x, and gives me x cubed, goes to the 4, and gives me the minus 4x squared. Now distribute the 3x, and gives me 3x squared. Distribute to the 4, it gives me minus 12x. Distribute the 2, gives me plus 2x. And distribute the 2 to the 4, gives me minus 8. Okay? So, simplifying now. So, let's get rid of all the highest powers. X cubed. Do I have any x squareds? Here's an x squared, there's an x squared. So what's that leave me? A negative 4 and plus 3 leaves me with a negative x squared. Alright, having x's. Negative 12x plus 2x leaves me with a negative 10x. And then my constant is minus 8. Okay. So I get my final answer here. I distribute the 1/9 and I get 1/9 x cubed plus 1/9 x squared. Note the negative times the negative gave me the positive. Again, 1/9 times a negative 10x. The both are negative, so it gives me a positive 10/9 x. And now distribute the negative 1/9 to the negative 8, and I get a positive 8/9. So that's going to be our final answer there. P of x equals a negative 1/9 x cubed plus 1/9 x squared plus 10/9 x plus 8/9. Thank you.